before we get to the point, who actually uses Cocoapods? Not bad. Who has heard about Cocoapods? Nice, cool. So again, before we get to the whole point of what Cocoapods are, let me talk a little bit about how can we manage dependencies in Cocoa. So up until Cocoapods age, we had basically two options, which is copy and paste and submodules, which are a little bit better. For copy and paste, usually copy and pasted files, then you had to add other linker flags, then you had to add arg flags if your project used arg and this module did not use, or the other way around. Then you had to add frameworks and of course other missing build settings like header search paths, and then resources, and then finally you can use the component. So what are the issues with this approach? First, you'll get issues with duplicate symbols, if there are any duplicate symbols. Say, you have a library A and B, and they both wanted to use AF networking, and they both pulled it in, and then you have this problem that, hey, I get duplicate symbols, what to do? And actually, up until this presentation, I had no idea there's a way of solving this, but you can actually use lipo tool to rip out the compiled symbols, which is insane when you think of it, that you have to do this. And of course, it's super hard to manage versions. For instance, you pulled in some sort of a, say, flowery version, and you have no idea which exact version is it, because no one ever writes what version of component do you have in code, right? I mean, you could imagine when you create a file where a programmer manually puts version of it, but then it's error prone. Someone can just forget about it, and then again, you have no idea which version of the component you're using. Then missing other linker flags and build settings. So for other linker flags, when you forget to add all load, am I right? The categories might not be loaded, right? And in that case, the app might crash at random points, because it'll have some sort of a category not loaded, somewhere in the code it will get called, and the app will crash. Of course, if you have awesome tests in the app, then it won't matter because you'll catch it up early. But on the other hand, you can add the other linker flags to just test target, and then again you have the same issue. And of course, issues with missing resources. So let's see how this compares to submodules. With submodules, you again have issues with duplicate symbols, right? Because when you add a submodule, then again, if it compiles to the static library, you have the exact same issue. Again, it's somewhat easier to manage versions because your submodule points to a very specific commit in the Git repo. But again, it only works for the version when someone properly tags versions. Again, other linker flags, and again, other build settings, and again, resources. So now having this said, let's see how can you add external library to your project using submodules. So you do git submodule add, then you do git submodule update, then you pick a specific version of that component, then you add sources to project, then you add arg flags, then you add frameworks and other linker flags, and then you add other missing build settings, and then you fix duplicate symbols if there are any, and then you add resources, and God, after 8 points, you can use the library, right? So this is all wrong, seriously. We should not do this. We are to create things, right? We are to write awesome software, we are to solve people's issues, and we should not spend time trying to add some sort of a simple library to my code, right? This is just wasting our time. So, enter Cocoapods. What are Cocoapods? Cocoapods' goals are to make working with dependencies simple. This is actually from their website. And the other is improve library discoverability and engagement by providing an ecosystem that facilitates that. In short, it's easy to search for other companies. So what are the advantages of Cocoapods compared to just copy and pasting? It will automatically handle source code and static libraries that are added to your project. It will automatically handle arc flags. It will automatically handle frameworks as well as build settings and resources. In short, it will just do everything for you. And the reason for this is because the responsibility for configuration requirements lie with the creator of component, not you. So the other guy who prepares the component is responsible for configuring it the way it'll work for you. So how can I install Cocoapods since they're so awesome? Well, it's very simple since they're distributed as a gem. So you can just type game install Cocoapods and you have Cocoapods. Now let's talk a little bit about basics of Cocoapods. So how do Cocoapods work? Let's start with a simple definition of a pod. Pod is a single definition of a component. By that I mean a single static library or a single part of code that you're going to use in your project. Then there is a pod file, which is a list of dependencies that your project has. Then it's very important at this point to point out that Cocoapods use semantic versioning. And as a reminder, it's major, minor, and patch. For instance, 1.2.5. It resolves dependencies list, all your dependencies and their dependencies have. So if one of my dependencies is dependent on, say, JSONKit, and I'm not using JSONKit in my project, it will automatically pull it in. And dependencies are actually definitions in a GitHub repository, and this will be very important at a later stage. So what happens when I install pods? First, Cocoapods will resolve all dependencies from your pod file, and as I said before, it will also resolve your dependencies and their dependencies. So it'll just build a huge tree what your project needs to run. Then it will take an Xcode project as a start and generate Xcode config files and attach them to your project. These Xcode config files will actually allow your your project to compile with given frameworks, because they found a nice way to link against frameworks by providing a specific Xcode configuration. And they also will do the other linker flags, header search paths, so on and so forth. Then they will generate another Xcode project that will build a static library with all the components that you defined and all the other components that your components depend on. Then it will generate an Xcode workspace with your project and the generated Xcode project. And then in the end, it will add a dependency on the generated project results to your target, so that your the dependencies you defined will end in your project as a dependency. And it will log all the used versions in the pod file log. So this will be important in a second. So basic commands. There are actually two basic commands. One is pod install, which just installs all the pods, and pod update, which will update all existing pods. And there is a slight difference that's kind of important between these two, so let me explain what's the difference. So pod install will, when there's no pod file log, it will use latest version of the pod that you defined, or the one that you defined in your pod file. So say if I wrote that I want to use just Mantle, they'll download the latest version of Mantle. Let's say I don't want to use the new fancy version, I just want to stick with the version 1.0. You can write that you want to use 1.0 and then it will use the 1.0 version. However, if there's a pod file log, you will use the version that is defined in pod file log or the one that is defined in the pod file, whereas the one defined in pod file is more important. As for pod update, it just ignores pod file log and it will work as if there was no pod file. Now, let's see what pod file actually is. It defines a platform and it defines the project that it should attach to, whereas this is actually optional since a few versions. It also defines your dependencies, or defines, as I said before, a specific version of the dependency. And you can define multiple targets to which it should attach. So you can, for instance, define a different target that it should attach to for, say, components that you use in specs or tests. So let's take a look at on a path file example. This is an example path file that I used in a demo project for a previous presentation. And as we can see, it defines the platform and iOS version. It also defines the project, which I mentioned before is now optional. It defines dependencies, and as you can see, I explicitly said that I always want Cocoapods to install version 1.2 of Mantle. And then it defines a target called Cedar, which then I ask it to link with Twitter user timeline specs, which is my target for tests. And into that target, I want to link the Cedar component. Now, a few tips. As with each and every component or library or, well, program that you use, something might go wrong. And in that case, it's good to know what to do to just clean up everything. As IT people, we have this notion that we can fix everything by just turning it on and off. And it's the same with Cocoapods. You can just wipe everything and then try it again. So this little command will actually try to delete as many caches as I have ever heard of for Cocoapods are. And another nice trick that we use a lot, which is moving patch version. Moving patch version will automatically update to new available patch version. And what I mean by that, if you write pod mantle and with that nice little arrow there, it will always update to version 1.2.x. So if I have installed version 1.2.0, but Cocoapods, but GitHub released a version 1.2.1, it will install the version 1.2.1 because I told it explicitly to do so. This is kind of strongly related to how semantic versioning is defined. Semantic versioning says that for patches, backward compatibility should always be ensured, whereas for minor and major version, their backward compatibility is not ensured. So this is why you can define that patches will be automatically installed. Now let's move to some fun stuff. Because I'm pretty sure that most of you thought that, hey, this is pretty awesome, but I have a lot of internal components that I don't want to share with anyone else and that I use in-house. And I don't exactly feel okay with open sourcing it. So Cocoapods also facilitates this. You can actually use Cocoapods for in-house components. And I really encourage you to do so. At Taptera, we have right now over 28 internal components that we use in our project, which range from analytics to helper libraries for the awesome Salesforce SDK. And it really made our life easy, that we could just define an external component, well, actually internal component, and then just in 3 lines of code, install it into one of our newly started projects. So how can you do this? What you'll need first, actually. You'll need Cocoapods installed, which is kind of obvious. You'll need an empty Git repository for specs definitions, and you're all set. That's actually everything that you need. So now let's talk about your own Cocoapod specs. So as I mentioned before, Cocoapods are actually, each component is actually a definition in a Git repository, and that definition is a single file. And if you want to create your own Cocoapod, then you need to prepare a pod spec. And let's take a look how an example pod spec looks like. Can everyone see this? Hey, people at the last row say it's okay, so let's stick with whatever we have. So this is a very simple pod spec, which defines an example component that I wrote for this presentation. I tried to stick with the most important parameters for or Cocoapods, or the ones that we found most useful in our development. So unfortunately, I won't be able to highlight what I'm showing, but I hope you'll follow on. The first is just the name. The name is kind of important because when you type pod search, which is the command for searching for pods, this is what will be searched. So it's very important if you want people to use your library to put something useful there. Then there's the version, which in my case is the first version, 0.0.1. Then there's summary, which is the summary that will show up in pod search too. Then there's the home page, which will also pop up in the search results. Then there's license, author, source code, and let's stop on source code. So this part is kind of important. It's how Cocoapods work when you define a specific version and when it wants to find a specific version. It goes to Git and takes that tag that I defined here as the tag it want to use for the version that it should download. You can also specify a commit, like a very specific commit. However, that is strongly disencouraged because it doesn't exactly say what's happening here. Whereas tags are superbly easy to use in Git, and you can just define that this is version 0.0.1, and then use that neat little thingy that will tell the Cocoapods to install that version, that GitHub repository with that version. And what I also seen a lot is that people actually write 0.0.1 here, which is kind of lame, because you can just use this little hash as version, and it will automatically pull the version from as version that you defined before. Then there's the platform, and then there's the iOS deployment target. So iOS deployment targets is very important to set. And the reason for this is, say you're using iOS 5 still for one of your projects, and you want to pull in a component that someone prepared, but then that component works only with iOS 6, right? And if you just pulled it in, then you wouldn't instantly know that there's something wrong, that you're using iOS 6 only component, right? Whereas here, if you define an iOS deployment target of 6.0 and somebody's project has a deployment target of 5.0, then the Cocoapods will explicitly blow up and say that they cannot install this version. Then of course you can define source files, you can define exclude files, which obviously will be excluded. You can define resources, frameworks, that will be automatically, let me underline this, automatically linked against your project. You can also define whether it requires ARC or not, other linker flags, and the dependency on JSON kit. So here I explicitly said that my example component, spec, wants to use JSON kit with version 1.4, and it has the moving flash version. So, moving on. Things that you'll have to do first before you can use your own awesome pod specification. You'll have to add your own specs repository to local Cocoapods repo list. As I mentioned a few slides before, Cocoapods use a single Git repository for all the specifications. And of course, Cocoapods creators don't exactly want everyone messing around with it. So they handle write flights very reluctantly, I'd say. But you're free to create your own Cocoapod specs repository. However, you have to tell Cocoapods that you have installed that you have done so. And then you need to push your new pod spec to that given repository along with the tag that you just created. Because as I said before, tags are used for Cocoapods so that they know which version they should download. And how can you add a custom specs repository? Well, this couldn't be easier. You just type pod repo add, the name of the repository, and the Git address of the repository, and you're done. It's also super easy with pushing to Cocoapods specs repo, where you just type pod push and then the name of the repository. And let's hope that our demo will work. There we are. Let's do this. So here's my example pod spec that I mentioned before. Let me bump the version to 1.2. And as you can see, I have modified the example component pod spec. Let me accommodate. Yep, let me tag it. And let's push it. Now, Jarek, I hope your phone is okay and it will push. Yes, it did. Now, I have pushed. Now I pushed the new version of the pod to the repository. However, the pods are not yet updated, so they have no way of knowing that the new version of my pod is already there. So what I need to do now is to tell Cocoapods that I have just prepared a new version of my pod. And as I said before, you can do this by typing pod push, and then you need to type the name of the repository, the Cocoapods repository that you defined before, because otherwise it will default to the master, the Cocoapods repository. And hopefully it will push the latest version. What Cocoapods do, they actually initially validate your pod spec so that you are certain that all is done well and there are no problems. This will not validate because I did some bad stuff there. But you should not actually do this very often, but you can silence warnings. And now it should work. Or not. You can also tell it to be verbose. And now let's see what's wrong. Yep, I did tag the comment. Oh, wait, you're right, I didn't push tags. Now it should be all right, after we do the push tags. Because what Cocoapods did, they looked for version 0.0.2 as a tag, and since there was no tag defined, they failed utterly. So now the validation should pass. Yay! As you can see, it also downloaded JSON-Kit to check whether it's also okay, and JSON-Kit throws a lot of weird errors, but now it's pushing to mobile Warsaw repository with the latest version. And I think if we go here, and wait for it to load. We can see that just now I pushed a version 0.0.2 of example component. Now it's fine. And that will be everything for this presentation. I hope you find it interesting.